It is Tuesday afternoon, and you are asking an AI the same question you asked it 2 weeks ago. You remember the last answer was perfect, but the session ended and that intelligence evaporated. This is the normal state of knowledge work in 2026. The problem is structural. Every conversation exists once, dissolves, and must be reconstructed from scratch the next time you need it. Every chat starts as a fresh computation. The model has no memory of the document you attached yesterday, and it doesn't notice when its current answer contradicts a decision your team made last month. Most organizations are spending real money on AI access while generating zero institutional memory. You are essentially renting the same insights over and over, instead of owning them. This creates a knowledge graveyard: stale Confluence pages, isolated Notion databases, and hidden SharePoint folders. AI has simply added a new wing of evaporated conversations to that graveyard. We pay a retrieve every time tax. For every new chat, the model rereads the same document and re-derives the same framework. RAG fetches the right chunks, but the expensive part, reasoning about them, still happens on every single query. RAG lowered the cost of finding facts, but it failed to lower the cost of understanding them. Without a place to deposit that understanding, you pay the synthesis tax every time you hit send. Knowledge compilation changes the math. Instead of performing the heavy lifting at query time, you transform your raw inputs into a structured, durable artifact once, and then you query that artifact forever. The architecture has 3 layers. Layer 1 is raw sources, an append-only directory for unmodified inputs. Layer 2 is the compiled wiki, where the LLM maintains pages and cross-links entities. Layer 3 is the schema, the core instruction document governing the system. By dividing the labor, humans curating the sources while the LLM handles the tedious bookkeeping, the system ensures your explorations accumulate value rather than remaining isolated queries. The foundational model for this is Andrej Karpathy's LLM Wiki. It's a minimal, session-driven approach that uses basic markdown files, making it highly portable and perfect for personal or small team use. However, manual wikis have a ceiling. Performance degrades once you pass a few hundred documents, and the system's health depends entirely on a human remembering to trigger the update cycle. For larger operations, Garry GBrain provides a production-scale implementation. It's built to run autonomously across thousands of pages without requiring a human to initiate every step. GBrain uses a Postgres backend and an agent layer that runs scheduled cron jobs. These agents continuously parse live data from Gmail, Slack, and calendars, filing new insights into the wiki 24/7. While the tools differ in scale, both make the same architectural bet: that durable knowledge should be compiled once and queried for free, rather than re-derived from raw chunks on every ask. Building this architecture generates a compile dividend. While the initial ingest has a small cost, every subsequent query is subsidized by the work the compiler has already done. This provides explicit provenance. Every synthesized claim in the wiki traces back to a dated source, allowing teams to verify information and retire facts that have been superseded. But there is a failure mode: the abandoned compiler. If the ingestion queue backs up and the maintenance stops, the wiki freezes and eventually becomes the very graveyard it was built to replace. Implementing a compiler requires an organizational commitment to maintenance. If you cannot name a specific owner and a regular cadence for running the system, it will fail long before the technology becomes the bottleneck. The dividend is only paid to teams that treat their knowledge base as a production system, something that requires active ownership to remain trustworthy. A wiki that has been ingesting and linting for 2 years becomes a structural competitive moat. It is a contradiction-resolved repository of institutional memory that grows more valuable with every entry. A compiling team moves with incredible speed because they navigate a lattice of existing answers, while their competitors are still opening fresh chat windows to ask the same fundamental questions for the 3rd time. Stop paying to rediscover what you already know. You are already having the conversations. Now, start compiling them.